HC Verma, Wave Motion and Waves on a String, Question 20. Let us visualize the setup. On the left we have a fixed wall. A string of length 40 centimeters and mass 10 grams is attached to the wall. On the right end, the string is connected to a spring with spring constant K equals 160 newtons per meter. The spring is stretched by 1 centimeter from its natural length. Watch as a wave pulse produced near the wall travels along the string towards the spring. Here is the full question. A string of length 40 centimeters and weighing 10 grams is attached to a spring at one end and to a fixed wall at the other end. The spring has a spring constant of 160 newtons per meter and is stretched by 1.0 centimeter. If a wave pulse is produced on the string near the wall, how much time will it take to reach the spring? The key concepts here. First, the tension in the string equals the spring force, because the string is in equilibrium. The spring force is given by Hooke's law, F equals K times X. Second, the wave speed on a string is V equals square root of tension T divided by linear mass density mu. And third, the time for the pulse to travel the entire string length is simply time equals length L divided by wave speed V. Let us solve this step by step. Given values, string length L equals 40 centimeters, that is 0.4 meters. Mass of string M equals 10 grams, that is 0.01 kilograms. So the linear mass density mu equals M over L equals 0.01 divided by 0.4, which gives 0.025 kilograms per meter. Step 2. Finding the tension in the string. The spring is stretched by extension X equals 1 centimeter, that is 0.01 meters. The spring constant K is 160 newtons per meter. By Hooke's law, the tension equals K times X, which is 160 times 0.01, giving us tension T equals 1.6 newtons. Step 3. Finding the wave speed. Wave speed V equals square root of tension T over mu. Substituting, V equals square root of 1.6 divided by 0.025, which is square root of 64, giving us V equals 8 meters per second. Finally, the time for the pulse to travel the string length, time equals length L over wave speed V equals 0.4 divided by 8, which gives us 0.05 seconds. The correct answer is, the time taken for the pulse to travel from the wall to the spring is 0.05 seconds, or 50 milliseconds. Here are some important tips. Tip 1. When a string is attached to a spring, the tension in the string equals the spring force Kx. This is a common setup in HC Verma. Tip 2. Always compute the linear mass density, mu, as total mass divided by total length. Convert units to SI first. Tip 3. The wave speed formula V equals root of T over mu applies to transverse waves on a string. Memorize this. Tip 4. Time of travel is simply distance over speed. Do not confuse this with the time period of oscillation. Like and subscribe for more HC Verma solutions at MAGPIEHUB. See you in the next video.